Swayam Prabha. Digital India. Educated India.
Hello dear friends, welcome to the second lecture of Module 8 on rock load and support system. In previous lectures we have elaborated about formation of damage zone during the excavation of an opening in geoground and factors relevant in estimation of rock load or ground pressure. Now in this lectures we will discuss about approaches for estimation of rock load ground pressure. In this lecture we are going to discuss about methods for determination of rock load through empirical approach in detail along with different methods in brief. Regarding this we are going to cover about different approaches utilized for estimation of rock load, categorization of approaches, and one of the approach, that is the empirical approach. Friends, as we have already discussed, during the excavation of an opening there is redistribution of stresses, and the redistribution of stresses try to regain about its original position. During the process of regaining or restoring original condition, the strata try to adjust with redistribution of stresses. If the redistribution of stresses exceeding the capability and strength of rock strata, then there is a development of damage zone around excavated opening. The weight of some potentially unstable zone that is formed due to creation of underground opening or unstable layer or detached layer or blocks is recognized as rock load. So in summary we can say that the dead weight of potentially detached, unstable, deformed, damaged zone is recognized as rock load. As the rock load experience on the ground in form of support system, therefore this aspect we are going to estimate in term of ground pressure also. In definition, if we are going to recognize, then we can say that the rock load may result from the dead weight of some potentially unstable layer or blocks of rocks or detached zone or deformed zone, as well as from the so-called ground pressure. Therefore, rock load we are also recognizing as ground pressure. You can see before excavation of this zone, the strata lying in the ground is in equilibrium state and in compact state. When we are going to excavate this opening, then there is a redistribution of stresses around this opening, and it is a nature of living and non-living both things. So the rock strata also try to restore its original condition. Therefore, the strata started adjusting with redistribution of in situ stresses and resulting in form of deformation if the capability of rock strata is not able to sustain with redistribution of induced stresses due to excavation of this type of opening. Simply the dead weight of, because this zone is detached from this original zone, so therefore simply weight of this detached zone or weight of this detached zone is recognized as rock load. The rock load can be estimated involving number of parameters which we have already discussed in detail. Regarding the approaches for estimation of rock loads, we are having empirical approach, semi-empirical approach, structural defect approach, rock support interaction approach, and unified or integrated approach of all this. So in this lecture we are going to elaborate about empirical approach. As we have already discussed the determination of strength in case of rocks, we have number of experimental facilities which are capable and able to show results concerned to strength and mechanical response of rock in case of general intact rock material. However, in case of rock strata, which is integration of the rock mass, and rock mass is consisting of the rocks and discontinuity are joint, therefore very difficult to test in experimental mode. Therefore, we are preferring to consider empirical approach, and the empirical approach to determine rock load. The rock classification is proposed since very early, and this classification proposed are many, and these are different in different countries. Several researchers have proposed classification of rock, but the classification of rock in geology is qualitative in nature, only provide the descriptions of rock. Nevertheless, the classification proposed by Tarjhangi in 1946 is the most fundamental one among all proposed rock classification, because this is the first approach to partially quantify the rock for engineering application. It is basis for their classification thereof concerned to the later researchers, and the modern version of this classification are those proposed by Deer et al. In 1970, 1969, Beniavsky 1973, and Barton et al. 1974, Hook and Brown in 1992, and many. A comparison of rock load in terms of dimensionless parameters suggested in the classification of Tarjhangi, as well as classification proposed by Barton et al., Deer et al., and Beniavsky, etc., etc. The rock load to be carried out by support member resulting from the structure of rock mass up to class 6 in Tarjhangi classification, and the true yielding of the surrounding medium in the rest of rock classes. Presently, number of attempts have been made to suggest different empirical relationship for determination of rock load or ground pressure for design of support system. Basically, the empirical approach is based on rock classification. Nowadays, the rock classification we are replacing by term rock mass classification. We have number of rock mass classification for our geotechnical issue and application. One of the first type of attempt made in this direction by Tarjhangi in 1946, although he started working in 1943. Tarjhangi considered structural joint of rock masses and classified on the basis of joint present in rock in 9 categories, namely hard and intact rock, hard stratified schistose rock, massive moderately jointed rock, moderately blocky and semi, very blocky and semi, completely crushed but chemically intact, squeezing rock at moderate depth, squeezing rock at great depth, and swelling rock. This classification was actually qualitative in nature but utilized for engineering approach. This concept was applied for a 5.5 meter wide steel or support railroad tunnel excavated in Alps during late 20s for providing railroad. It was probably first attempt of its kind Earlier, the geologists have attempted to categorize rocks in very descriptive manner that cannot be satisfy the engineering use except description of rocks. As per Tarjagi classification, you can see if there is no any joint, then he has recognized such type of rock as hard and intact. If there is joint or discontinuity in form of linear interfaces, then recognized as hard stratified schistose rock as class second. Then in class third, massive but the presence of limited joint. In class 4, moderately blocky and semi. The rock strata or rock is traversed by limited number of joints and traversed by some weak zones like seam. Then very blocky and semi traversed by number of discontinuities and traversed by number of seams in different orientation, recognized as very blocky and semi. Then the crust rock but chemically inert or chemically intact. The chemical solution cannot deteriorate or decompose. This type of rock is recognized as completely crushed and but chemically intact. Then squeezing rock at moderate depth and squeezing rock at great depth as class 7th and 8th. Then the swelling rock that is dominated by some minerals belonging to clay which are prone to show expansion in volume after absorbing water. You can see the water molecules present here, and due to this water molecule presence there is expansion in volume recognized under swelling rock. As far as squeezing is concerned, squeezing is a very typical type of phenomena. Here I try to explain. When we are going to create any opening in rock strata, if this created opening is located in squeezing ground condition, then what happens? As per rule, due to creation of this opening, there is a redistribution of in situ stresses, and the redistribution of in situ stresses resulting formation of damage zone around opening. This formation of damage zone around an opening in general defined by some stand-up time of few hours, few weeks or few months or few seconds or 0 second depending on the nature of geoground. If the stand-up time is suitable for suppose 5 hours, 5 hours we are not getting the extension in formation of damage zone, then okay, we are able to provide the lining another and then going to support this type of opening. But in case of squeezing, there is a continuous increment in formation of damage zone with respect to time. The formation of damage zone become dynamic in place of static. Therefore, it is very difficult to estimate rock load or ground pressure to provide a support system of defined capacity. Due to continuous increase in volume of damaged rock, it is very difficult to line or provide support system to stabilize created opening. Due to continuous increase in formation of damage zone, the damage zone started moving from all sides toward the center of the opening and finally resulting the collapse of the opening in very bad condition. Therefore, we are forced to wait for stabilization of this type of phenomena, and this type of phenomena is recognized as squeezing phenomena, and the ground prone to such type of phenomena is recognized as squeezing ground condition. This squeezing ground condition depends on many factors, depends on depth of opening, about diameter, types of rocks, quality of rocks, condition, saturated condition, non-saturated condition, etc. Swelling rock is dominated by clay mineral bearing rocks such as shale, such as clay stone, siltstone, other phyllites, etc. When the clay minerals, as per rule, some clay minerals, good example, Montmorillonite, when this clay mineral is going to interact with water present in ground, then the water molecules absorbs between the tetrahedron present in clay minerals. You can see this type of tetrahedrons, then octahedrons, then tetrahedron. Overall the structure also, the water started entering inside this, here octahedron, then tetrahedron and tetrahedron. So water lying between this tetrahedron and going to increase the volume of clay minerals, and the clay minerals present in rock, therefore there is increase in volume of rocks. So that type of rocks we are going to recognize. Later, after classification, the Tarjhangi has given some load value in term of rock load factor. The similar categorization later he has utilized for calculation of rock load. First here you can see the Tarjhangi integrated the result of trapdoor experiment and the estimated rock load from the alpine tunnel to compute rock load factor as HP in term of opening width and the tunnel height HT of the loosened rock mass or rock. At that time there was no concept of rock mass. Earlier the peoples have recognized the rock mass as rock. Above the tunnel crown and which loads the steel arches, because the concept of Tarjhangi was fully based on a trapdoor experimental results and experience in 5.5 meter diameter tunnel located in Alps with steel arch support. He has elaborated about rock load factor for all his 9 classes of rocks in tabular form. In general, here I try to explain. As per concept of Tarjhangi, when the strata is disturbed by excavation of an underground opening, you can see underground opening, then due to creation of this opening there is a redistribution induced formation of damage zone. This damage zone around an opening. The dimension of the damage zone more toward the crown side of this tunnel. This is the crown of tunnel, and sideways slightly less. So Tarjhangi has estimated about the height of this damage zone by the term HP for a tunnel having the height from the crown as HT, and this whole opening is located below the surface as H depth. Then the vertical pressure can be calculated in very simple way. PV is equal to unit weight of rock multiplied by height of potentially loosening zone. This height of potentially loosening zone, this height above measured from the crown of tunnel. In simple way, if we are going to utilize full support, then we are going to consider this H also. But originally we are utilizing this PV is equal to gamma into HT, where the PV is a vertical pressure and the gamma is unit weight of rock material. HP is the height of extraction induced damage zone or loosening zone, and H is the tunnel depth, where the thickness we are going or span of opening is recognized as B. So its tabular classification to support 9 categorized rock classes. Tarjhangi has presented the rock load factor in term of HP, in term of tunnel opening height and the width of opening for excavation using drill and blast. You can see Tarjhangi rock load classification. he has presented or categorized 9 classes. For hard and intact rock, as we have already discussed, there is 0 HP, means there is no formation of, it may be in feet originally, but maybe meter, maybe any unit. So hard and intact rock is not going to show, not form any damage, therefore HP 0. Where the light lining required only if spalling or propping occur, otherwise there is no requirement of any support. The next class is a hard stratified rock or schistose rock, and the rock load factors ranging from 0 to 0.5 span multiply by the span of opening or B. In this case, light support mainly for protection against spalling, otherwise there is no requirement of. But in this hard stratified schistose rock, due to mode of failure of such type of rocks, in general, the load may change erratically from point to point due to presence of this stratification and schistosity present in rocks, as practical experience. Then third class is a massive moderately joint, where the rock load can be estimated simply, which can range from 0 to 0.25 multiplied by B. And the remarks for support system is concerned to this light support, same as above. Next class is the fourth class, that is moderately blocky and semi. The moderately blocky and semi can be recognized for the calculation of the rock load in term of HP 0.25 B to 0.35 B plus HT. No side pressure observed. In case of fifth class, that is very blocky and semi, where the rock load is ranging from 0.35 to 1.10 B plus HT. Little or no side pressure observed. Sixth class, completely crushed but chemically intact, where the rock load factors we can calculate as 1.10 B plus HT, where B is the width of the opening and HT is the height of opening. Considerable side pressure observed. Softening effect of seepage toward the bottom of tunnel requires either continuous supports for lower ends of ribs or circular ribs sufficient to stabilize such type of. Seventh class is squeezing rock. This is the very typical type of rock, creating lot of problem, increasing load and other, but Targhagi anyhow presented this relationship 1.10 to 2.10 B plus HT. You see about the value magnitude of the rock load, and here as in remarks you can see heavy side pressure inward stress required, circular ribs are recommended. Here the support system is in squeezing ground condition is very difficult due to continuous increment in rock load and creating lot of certainties. In case of one tunnels located in main boundary thrust in Himalayan area, waited for 6 months, ultimately we are forced to divide the diameter in 3 divisions, and then successfully we have constructed tunnels in MBT in Uttarakhand. Squeezing rock at great depth, you can see 2.10 to 4.5 B plus HT, and the same type of precautions required in such cases. And the case 9, swelling rock, here up to 80 meter, irrespective of the value of B plus HT, circular ribs required. In extreme cases, use of yielding support recommended. Later on, the classification of Targhagi was modified Deer et al. In 1970. Deer et al. Has added RQD parameter, rock quality designation. The rock quality designation is simply summation of sound core more than 10 cm divided by drill length multiplied by 100. Very simple parameter utilized for categorization of rock mass or rock strata. So Deer et al. Has modified the Targhagi concept, added some class additional, but applied RQD as a column. You can see hard and intact rock ranging In RQD from 95 to 100, 0 rock load factor, same remarks as observed in case of Tarjagi. Hard and stratified or Stoj rock, which is measured in term of RQD from the 90 to 99, and this load factor is 0 to 0.5b. All terms we have already explained. Massive moderately 85 to 95, 0 to 2.5b as observed in case of Tarjagi. The precautions or remarks are same as observed in case of Tarjagi classification. Then fourth class, moderately blocky and semi, defined by RQD ranging between 75 and 85, where the 0.25b to 0.3b plus HT is required as we have already observed in case of Tarjagi classification. Type 4, 5th, 6th, reduced by approximately 50% from the Tarjagi 1946 classification values because water table has little effect on the rock load. Next, 5th, very blocky and semi, categorized by or characterized by 30 to 75 RQD value. Then completely crushed. Here you can see in Tarjagi classification, this was completely crushed but chemically intact. But in case of modification by Deer et al. In 1970, they have suggested completely crushed only, omitted this chemically intact term. Another, he has added 6A, sand and gravel as additional class. So completely crushed rock defined by RQD ranging between 3 and 30, and the rock load factor is ranging 0.6 to 1.10 B plus HT, and the same concept as given above. Next, sand and gravel defined by RQD 0 to 3%, and this condition the load can be calculated as 1.1 to 1.4 B plus HT, remarks as same as above. For the class 6 squeezing rock moderate depth, the same concept we have observed as in case of only. Here for squeezing rock at moderate, squeezing rock at great depth and swelling rock, there is not possibility to determine RQD value. Therefore, these rocks are very difficult to estimate or insert support system. There is some limitations as described by Singh and Goyal in 1999. Observations in form of observations on Tarjagi classification based on measured values suggested. Is classification useful for small tunnels where the diameter is limited up to 6 meter only. Tarjagi methods provide reasonable support pressure in such cases. For large tunnels and caverns ranging between 6 meter to 14 meter, it provides overshape estimate. So problematic. And for squeezing and swelling ground condition, estimated rock supports fall to a long range and not practical for use. Then we have number of approaches for estimation of ground pressure, where the annals have suggested one concept very simple. PV. Besides Tarjagi, number of researchers have also attempted this problem and suggested support pressure in term of rock mass rating system, in term of height of the tunnels, etc. So as per concept given by annals, the estimated ground pressure PV can be measured as 100 minus RMR by 100 into unit weight of rock into the span of opening. And another approach by Goyal and Jetwa we will discuss again in our next class is a 0.75 power B power 0.1 H power half minus RMR divided 2 RMR MPa, and B is span and H is OB. We will discuss in next class for continuity. This type of material we have prepared from different research papers and book written by Singh and Goyal in 2006, namely Tunneling in Weak Rocks, published from the Elsevier as Geoengineering book series, edited by Professor John A. Hudson of Imperial College, ranging in page from 1 to 489. Then paper related to rock tunneling with steel support, very old paper, and proposed by Tarjhangi, taken from the book Bhutkuri and Matsuyama, written in 1940, Introduction to Rock Mechanics, published in Japan. Very simple book, describe the research output of many researchers. Then the paper by Deere et al., Deere, Peng, Carby, Parker, H., Monsees, J., and Smith B. Design of Tunnel Support System, High Research Recognition 399 number, and page 26 to 33. Partial support from the Engineering Geology book written by Well in 2007. Friends, we have discussed elaborately the concept proposed by Tarjhangi. The Tarjhangi concept or proposal was the first approach in estimation of rock load. Earlier, all the classification was purely qualitative and utilized for description purpose only. The excavation in rock strata is causing change in in situ stresses in localized zone, therefore formation of damage zone, and that damage zone is representing the rock load. Tarjhangi's method is applicable for small tunnels, not suitable for large tunnel, as commented by number of researchers Singh and Goyal and Bortons and others. In addition to this, RQD is more informative in categorization of different type of rock classes as additional support, supplemented by Deere et al. In 1970, and this method is not valid for large tunnel and showing lot of scatter in data. Dear friends, in this class we have elaborately discussed about concept of rock load and ground pressure and different type of approaches in brief, then in detail about the empirical approach proposed by Tarjhangi and advocated by Deere et al. In 1970. Some of the approaches except Tarjhangi and Deere also important for estimation of rock load, which we will discuss in our next class. Thank you very much.